Hello, dear students. Today we're going to do Proposition 28 from Book 1 of Euclid. Proposition 28 is really two little propositions together, but we'll do them as one like Euclid does. If there be two straight lines, and a straight line falling upon those two straight lines, creating an exterior angle equal to the opposite and interior angle on the same side, those two straight lines are parallel. Also, if there be two straight lines and a straight line falling upon them, creating the interior angles on the same side equal to two right angles, those two straight lines are parallel. So here's the first prop. If there be two straight lines and another straight line falling upon them, creating an exterior angle equal to the opposite and interior angle, those two straight lines are parallel. If there be two straight lines and a straight line falling upon them, creating interior angles on the same side equal to two right angles, those two straight lines are parallel. Let's go to our bag of knowledge. Today, to do this Proposition 28, we're going to rely on Proposition 15, where we've shown that vertical angles are equal to each other. If there be two straight lines falling upon each other, the vertical angles are equal. These two are equal, and these two are equal to each other. Then we're going to use the previous prop, Proposition 27, which states if there's two straight lines and a straight line falling upon them, the alternate interior angles are equal to one another. And then we're going to use Proposition 17, which states if there be a straight line falling upon a straight line creating adjacent angles, those adjacent angles are either actually two right angles or equal to two right angles. Then we're going to use some common notions, a couple of common notions. Two things equal to the same thing or equal to each other. And then we're going to use a common notion when you subtract equals from equals, the remainders are equal. So subtract these equals, the remainders will be equal. Okay? Let's get started with the first half of the proposition. So let it be that this is a straight line, and a straight line falling upon them. And let it be as a given that this angle, the exterior angle, is equal to the opposite and interior angle on the same side. I say that if that's the case, then these two straight lines are necessarily parallel. Let's do this. Now look at this line here by itself together with this line. Forget about this line for a moment. See these vertical angles? What do we know about vertical angles? That vertical angles are equal to one another. So this angle is equal to this angle. But this angle is equal to this angle, okay? So we have two things equal to the same thing. Therefore, those two things are equal to each other. This angle is equal to this angle, and this angle is equal to this angle. Therefore, this angle is equal to this angle. Look what we have here. We've got two straight lines and a straight line falling upon them, creating alternate angles equal to each other. We know from the previous proposition that those two straight lines are necessarily parallel. So this is necessarily parallel to this. So we've seen that if there be two straight lines and a straight line falling upon them, and the exterior angle is equal to the opposite interior angle on the same side, those two straight lines are parallel. Now let's go to the other given. If it's given that you have two straight lines, it's another proposition within the prop. Two straight lines, and now it's given that the two interior angles on the same side are equal to two right angles. If that's the given, then we can also show that those two original straight lines are parallel. How? Okay, so it's given that this angle and this angle are equal to two right angles. But look what we have here. We have a straight line falling upon a straight line, creating adjacent angles. And we know from Proposition 17 that when you have a straight line and another straight line falling upon them, creating adjacent angles, those two adjacent angles are either actually two right angles themselves, or they're equal to two right angles. So here we have a straight line falling upon this straight line and adjacent angles. Therefore, this angle and this angle are equal to two right angles. But look, this angle and this angle are equal to two right angles. That's a given in this prop. That's a given. So it must be the case that this angle and this angle are equal to this angle and this angle because they're both equal to two right angles. So this and this are equal to this and this. Look at, we have something in common between those two. Let's take out what's common. Now we know that you have things equal and you take out equals, the remainders are equal, okay? So this and this are equal to this, and you take out what's common, the remainders are equal. Therefore, this is equal to this. Look what we have here. Two straight lines with a straight line falling upon them, creating alternate angles equal to each other. And we know, therefore, from the previous prop that those two straight lines are necessarily parallel to each other. Great! So we have shown that if there be two straight lines and a straight line falling upon them, creating an exterior angle equal to the opposite interior angle, those two straight lines are parallel. Or, if in another case, another given, that if the interior angles are equal to two right angles, those two straight lines are necessarily parallel, which was to be demonstrated. Quod erat demonstrandum. Thank you. Bye-bye.